In this video, I'm going to explain how to add vectors graphically, and we'll do an example in just a moment, but first I want to give you the big idea of what's involved in adding vectors. So to add vectors, we would need two vectors to add. So I'm going to draw one vector here that is 5 squares measured on. There's a grid on the whiteboard, so that's 5 squares to the right. And I'm going to have a second vector that goes up diagonally and is this long, which is 3 squares diagonally. So these are my two vectors that I want to add. When you add vectors, the first step is to draw one of the vectors, and it doesn't matter which vector you start with. So I'm going to start with this one. So you first draw the vector, and when you draw it, you have to be careful to keep the length and the direction the same as the original vector. Otherwise, you're making a different vector. This vector, I now want to add to this vector. To add vectors, you have to take the second vector and put the base of it at the arrowhead of the first vector. So I'm going to take that second vector and draw it starting here. So it's going to go up diagonally 3 squares. And you would be doing this with a ruler, so that would actually be a straight vector. So now we have shown vector 1 plus vector 2. But to find the answer to the vector addition, we need to draw the answer vector, or the resultant vector. The resultant vector goes from the base of the very first vector you drew, which is here, to the arrowhead of the last vector that you drew when adding. So take a ruler and draw a straight line connecting those points. The arrowhead of the resultant vector is over here. So the base of the resultant vector is at the base of the first vector. The arrowhead matches up with the arrowhead of the last vector that you added. And this is called the resultant, or it's also called the vector sum. Okay, so the basics of adding vectors are: first draw your first vector, either one. Take your second vector, draw it beginning at the end of the arrowhead of the first vector, and then the resultant vector goes from the base of the very first vector you drew to the arrowhead of the last vector. And then you would need to measure the angle as well, because this is a vector and it has a magnitude, a length, and a direction. So that's an overview. Let's do an example to see how it works when you actually have numbers involved. So we have a child runs 30 meters east, then 20 meters at an angle of 40 degrees south of east. What is her displacement? So we can't just add the 30 and the 20 and get 50, because these things are not along a straight line. So we're going to have to add these vectors using a graphical method. The first step is to set a scale, because you cannot draw a vector that is 30 meters long on your paper. So we're going to choose a scale that would fit. You would choose something that would fit on a piece of graph paper. I'm going to choose something that fits nicely on the whiteboard. So 30 meters, a good scale for the whiteboard would be 1 centimeter being equal to 1 meter. The second step is to convert your vectors to the scale, to scale them. Now normally, this one in any case, you can do in your head. This is a really simple scale I picked. If your scale's not so simple or you get stuck, I'm just going to show you the mathematical method to scale them, just as a little safety net. So our first vector is 30 meters. To convert it using the scale, I'm going to multiply by the scale as a conversion factor. I'm going to put meters on the bottom because I want the meters to cancel out since I'm converting to centimeters. So this is going to give us 30 centimeters, canceling out our meters. Okay, so we have scaled one of our vectors and found out that it would be 30 centimeters long using this scale. The other vector, 20 meters, is going to be 20 centimeters long. Once you have your vector scaled, you're ready to draw your scale diagram of the vector addition. So the first step when doing that is to draw one of the vectors. Okay, and I'm going to choose to do the 30 meters east. So I'm going to start my vector here. and draw a vector that's 30 centimeters long, which takes me to here. Okay, so that is the first vector, which is 30 centimeters long, representing 30 meters as the original vector. The next step is to add the second vector. So we drew one of the vectors, and then we need to add this next vector. Okay, and the way we add the vector is to put its base at the arrowhead. Wherever you just finished, that's where the next one goes. To help with getting the direction, I usually draw a little coordinate system at that point, because this is where you're going to need to measure the direction from. So my vector is 20 meters at an angle of 40 degrees south of east. So this is east. So south of east means start at east and go southward that many degrees. So 40 degrees, it's going to be down this way. So we need a protractor for measuring the angle. So put your protractor here, center it on that point at the arrowhead of your first vector. And measuring 10, 20, 30, 40. 40 degrees is in this direction. So this is where I'm going to draw my 20 centimeter vector. It's along that direction, and it needs to be 20 centimeters long. That vector looks like this. So this is 20 centimeters, representing the actual 20 meter displacement. Well, now we're ready to draw the resultant. We have shown the addition of the two vectors, but we haven't shown the sum. The sum resultant vector goes from the base of the very first vector to the arrowhead of the last vector. So get a ruler, connect those 2 points. I'm sure this will be much more accurate when done on graph paper with a sharp pencil and a ruler. Okay, this is the resultant, it's the sum. To find out the size of this vector, we just have to measure it and then convert back using our scale. So when I measure it, I am getting that it is about 48 centimeters. And using the scale, you can convert back to the actual values, and that gives me that it is 48 meters, that the child actually, their displacement from where they started is 48 meters. This is a vector though, and so in order to specify a vector, you have to give its magnitude, which is its length, and you have to give its direction. A direction of a vector is always measured at its base, and you have a choice here. You can give one of two angles. So first draw a coordinate system, since this is where we're going to measure the angle of this vector. So north, east, south, west. If you measure this angle here, you would be specifying the degrees south of east. Alternately, you could measure this angle, and then you would be giving the number of degrees east of south. So you could do either one, just be sure you get the directions going correctly with the angle that you measured. So lining the protractor up on this point, we're looking for the direction of the resultant vector. So as I measure it, it looks like about 16 degrees. So now we're ready to answer the question. Although I should put that the fourth step was, let's first put the fourth step. The fourth step is draw the resultant. And then we need to measure length and the direction. We have to use the scale to convert back to the actual values that the problem was in. So I need to convert the length. Okay, so to state the result of our problem, we would say that the child's displacement I would say the displacement is 48 meters, and the direction was 16 degrees south of east.